Alright, here we go. So, a blank is two or more equations with the same variable. What is that? System of equations, right? It's in the title right there. So what we're going to do in this chapter is we're going to go back over Algebra 1 at the beginning, and then we're going to add on and do some Algebra 2 stuff at the end, okay? All right, so systems of equations can be classified by the number of solutions, okay? So this is where we need to make sure that we highlight this part. Y'all ready? All right, so Jackson, read that first sentence.
A system of equations.
No, the one that we're on, dear.
A system is blank if it has at least one solution.
All right, let's go right there. So it is consistent if it has one solution, at least one solution. So at the top up here, we're going to draw ourselves a picture because y'all are very visual, right? So consistent can look like one of two things. If it has a solution means that they cross, because we have more than one graph, so it could mean that they cross, or it could mean that they're just both the same exact line. What do I mean by both the same exact line? Like 2x plus y equals 3. Well, oh, same slope and same y-intercept, right? Are those two the same exact line?
Yeah.
Why? They look different. Brayden, are you with me there?
You subtract.
If you subtract that 2 over, what do you get? Negative 2x plus 3. Those would be the same line. Are y'all okay? All right, so these are both consistent. Make sure you write consistent. I can't spell today. Did I spell that wrong? I did spell that wrong, didn't I? Goodness gracious. All right, these are both consistent. So Jackson told us that it's consistent if it has at least one solution, and it is inconsistent. There you go. Let's see if I can spell it right this time. If it has no solution. Well, guys, if it has one solution when they cross, what would no solution look like? What? I can't hear y'all all spoke at the same time. I just couldn't hear it. What's the graph going to look like if they're not no solution?
Parallel.
They're parallel. Very good. So you have two parallel lines would be inconsistent. All right, so if it is consistent, and only if it's consistent, then it can have two options, either independent or, what's the other one? Dependent. Oh, y'all can't see that, can you? Is which one? No. Okay, so look what it says. If it has exactly one solution, so you see the picture that we drew with exactly one solution? Let me pull this up a little bit. So if it's one solution, then it's independent. So let's go back to our picture. This one had one solution. One because it crossed at how many points? 1. So we can call that consistent and independent. All right, if it is an infinite number of solutions, so what does that mean, an infinite number of solutions?
Keeps going.
Keeps going forever and forever. So every single one of these dots, no matter how high or how low that you go, every single one is going to be the same, right? So if it has an infinite number of solutions, then we will call it a dependent. Make sure you get that picture at the top because y'all are very visual people, and that's a lot easier to look at. And if it's inconsistent, you just call it inconsistent and you're done, okay? Just like, remember how we did function and not a function? If it was not a function, we were done. And if it was a function, we either had to call it one-to-one or onto. Do y'all remember that? Y'all okay? Y'all with me? Gabe, you okay? I mean, Gage, you with me? All right, here we go. So let's solve it. So what would I need to do first on the first one to solve it? What would I do with the x? Come on, y'all wake up with me today. Come on. What would I do here? How do I move it to the other side? Subtract it. There you go. Come on now. I know it's Friday. We're not done yet, though. All right, so I would get 2y equals negative x plus 6, right? Okay? And then what would I have to do to get rid of the 2? Divide each one by 2. All right, so what would I get? Y equals what?
Negative x plus 2.
There you go. So let's graph it. 1, 2, 3. We're going to go down 1 and right 2. Now look, you got to go all the way across the graph on this. Because if you don't graph it big enough, you may not see if they cross. All right, so it says y equals. Y equals means that it's always going to be what kind of a line?
Closed.
Closed. There you go. All right, then we got to graph the other one. If you got a different color, let's get a different color real quick. All right, so I have 2x plus y equals 9. What would I do to graph that one? What do I have to do first? Subtract 2x. Thank you, Harrison, for being with me today because everybody else is asleep. Come on, y'all wake up. Don't start that yawning. Don't start it. All right, y equals what? How much?
Negative 2x plus 9.
Very good. So I'm going to go up 9. Ooh, it's up here a little bit. And then I'm going to go down 2, right 1. Go as far as you can so that way you can see where they cross. Okay, so what kind of graph is that? Is that is a consistent and independent? Are y'all okay? What's the point where they cross? 4 and 1. Very good. Perfect. All right, y'all try number 2. Y'all try number 2. Make sure you label it consistent and independent, and that they cross at 4, 1. I see why some of y'all are so quiet, and I know I'm already working on number 2. Alright, check your first one. Make sure you get the same thing as the first one I got. All right, y'all get that? Two parallel lines that are really, really, really close together. Y'all okay? Yeah? Yeah? We awake? Come on. We okay? All right, what kind of graph is that? That is not a consistent and independent. Inconsistent. Did y'all do the graphs at the very top of your paper? Did y'all do those? Yeah? All right, so does it have a point where they're ever going to cross? No, so it doesn't have a solution. All right, let's go to the next one. Come on, flip over. All right, 3 and 4. Y'all try 3 and 4. See what you can do on 3 and 4, okay? Did you get that? For number 3? Yeah? So what do we call it? Beautiful. And what's the point where it crosses? 4 and 0 is the solution. Very good. 4 and 0 is the solution. Perfect, perfect. All right, keep going on 4. Okay, did y'all get that they were the same graph? Yeah? So what would we call that if they're the same graph? How much? Inconsistent. Very good. Good job, guys. Y'all okay? I mean, not inconsistent. Golly, not inconsistent. Consistent and dependent. Goodness gracious. Thank y'all. Keep me straight today, okay? Golly almighty. Are y'all okay with that? Anybody lost? I need some feedback. Y'all okay?
Slow down a bit.
I can. Do I just need to slow down, or are you okay on this?
Yeah, I'm fine.
Okay, that's fine. I'll slow down. next one, guys, you're going to get the same exact answer on the next one. If I were to graph number 1, you'd get the same answer if you were going to do substitution. So look at your learning target. What's the next thing that we're going to learn how to do today besides graphing? Using substitution, right? You go to the cashier, right, guys? And you give her $10. What could she change out your $10? What could she substitute your $10 for? 2 5s. What else? 10 1s. How much? Yeah, you do have $2 bills. That's true. So you can change them out. They're going to look different, but they mean the same thing, right? So look right here. What can I substitute x for? Instead of x, what can I put in for x? Negative 5y plus 3. Do you see an x in the second equation? Right here, right? So we're going to say 3. But then we're not going to put x. We want to replace x with how much? Perfect. And then what came after 3x? Minus 2y equals negative 8. Is everybody with me? Gage? Gage? You with me, dear? You sure? Positive? Okay. You have number 1? Okay. Alright, so what can we do from there? Distribute. And you get, I'm going to move over here. You get negative 15y plus 9 minus 2y equals negative 8. So now look, guys, once we plug that in, what's the only letter that we have now? Y. So now we can solve for y. So I've got negative 15 minus 2y. Those are on the same side of the equal sign. So what's negative 15 minus 2? Negative 17y plus 9 equals negative 8. Yep. So if I subtract it, what's negative 8? Very good. And then if I divide by negative 17, what do I get? 1. All right. Do you remember? Look back at number 3. We got an ordered pair where they cross, right? What's the only part of that ordered pair we found so far?
Y.
We've only found the y. So now what do we have to do with that y value to figure out what our x value is?
Plug it in.
All right. It doesn't matter which one you plug it into. But what's the easiest one to do? The top one, right? So I'm going to put x equals negative 5y plus 3. You can go ahead and plug in if you want to. Most of you could probably give me your answer in your head. What's your x value? So let's write our answer. What is this? 1. Perfect. So that means if I were to graph those, what would happen if I were to graph those? That's where they intersect, right? So what kind of, what is this? Is it consistent, inconsistent, independent, dependent? What is it? Consistent and independent. There we go. All right, let's try number 2. What's wrong with number 2? If it says substitution, what did we look for in number 1? We had a letter by itself, right? Ooh, that might be a really good note to write down for substitution. Gotta get one by itself, right? So it might be a really good note to write for substitution. What do we need to look for when it says substitution? A letter by itself. You might want to write that down somewhere. That's a really good note to write for substitution. It's a really good note to write for substitution, right, Gage? Did you write that down? Did you get enough sleep last night? Okay. All right. So which one of those is going to be easier to get by itself? The top one or the bottom one? The bottom one. It doesn't matter which letter I get by itself? No. All right. Which one do you want to get by itself? The X or the Y?
Y.
You do the Y? All right. So if we do that, then that's going to become Y equals negative X minus 12, right? So instead of Y, what can we plug in? Do you see a Y somewhere in that other equation? Right there next to negative 3, right? All right, here we go. So let's read that equation. That equation says 2x minus 3 But I won't put y. I'll put what y equals negative x minus 12 and then equals 6. All right, distribute that bad boy. Y'all okay with that? All right, so now I have 2x plus 3x. How much is that? Come on, 2 plus 3. 5x. All right, subtract that 36 to the other side. What's 6 minus 36? Negative 30. Divide by 5, and what do you get? Negative 6. But if I were to graph those, I only have the one part of my coordinate. So now I got to plug it back in. Which one is going to be the easiest to plug back into? The bottom one. Does it matter which one I plug into, the original one or the one where I moved it? Nope, they're the same thing. So we're going to have y equals negative x minus 12. So y equals negative 6 minus 12. Y'all okay with that? All right, so what's my order pair? So if I were to graph that, what would happen right there? They would do what? Intersect right there. And so what would we call that if they intersect, if they have one solution? Consistent and independent. There you go. Let's flip over. Go to the next one. Come on, come on, come on. Let's go. Independent. All right, here we go. All right, we got 2 more to do. You think you can try 3 and 4? Yeah? All right, y'all try 3 and 4. Let's see if we can get to elimination and kind of get caught up from the storms a little bit. So if it says substitution, what do you got to have? A what, Ryan? A variable by itself, right? So which one of those is going to be easier, the top or the bottom? Why the bottom? Because it doesn't have a number, right? It's easier. So try getting the bottom one, solve for x. So when you solve it, make sure you get x completely by itself, no negative or anything. Like that. Keep going. Make sure you got x, the same as what I did. Hmm? Alphabetical order. Alright, so did y'all get 18 equals 18? What's that mean? It's all real numbers. And Ken, if I were to graph that, what is it going to look like? It's going to be the same line. And we call that same line what? Consistent and dependent. Are y'all okay? All right, what about number 4? Y'all okay on number 4 so far? Which one was the easier one to solve on number 4? The first one, right? So you should get A equals 3B minus 22. Okay, and we're going to plug that in right here. And Kenan brought up a really good question. Kenan, what was your question again?
If they use A and B, how do you know which one's X and which one's Y?
All right, so alphabetical order. What would be your X in this case? What would come first in your order pair? A, and then what would come second in your order pair? B, right? Try number 4. Try number 4. All right, y'all get that for your answer? Still okay? Yes? No? Get off Snapchat? What's your order pair? Beautiful. Beautiful, beautiful. Y'all okay? Yeah? All right, let's catch up a little bit from being out from the storms. And let's look at the next one. So if we're going to solve by elimination, what do you think our learning target would be for this one?
Solve by elimination.
I can solve systems of equations using elimination. All right, so what were we looking for if we were doing substitution? A variable by itself, right? But we're doing elimination. So when you're doing elimination, you don't want a variable by itself. You want the same number with the same letter. What number's with M? What number's with M here? What number's with N? -1, what number's with N here? Do I have a number with the same letter? Or do I have the same number with the same letter?
No.
So you have to make it be that way. So real quick, make yourself a note for elimination. When it says to use elimination, what are we wanting to look for? Same number with the same variable. There you go. So make yourself a note. So which one of these do you want to make be the same? Do you want to make the M's the same, or do you want to make the N's the same? It does not matter. It does not matter. Which one do y'all want to do? N because it's closer?
Yeah.
Okay, so you got a 1 right here, and you got a 2 right here. So you're going to have to multiply, and if I multiplied that top equation, what number would I need to multiply to make this 1? I don't care about signs. Don't worry about signs. What number would need to be multiplied by 1 to make it the same as 2?
2.
2. And then if you do it to 1, you got to do it to every single one of those, okay? So you have 2m minus 2n is equal to -18. And I didn't do anything to this bottom guy, so I'm just going to bring him back over. Y'all okay so far? This is just Algebra 1, okay? Alright, so now you're either going to add or you're going to subtract. So the word is eliminate. That means I need to make them go away. How do I make these go away? By adding or by subtracting? By adding. So I'm going to add everything together. So I'm going to add my m's. What do I get when I add the m's? 9m. What do I get when I add the n's? They cancel out. I don't have to write the 0. And then what do I get when I add my constants? -9. Divide, and what do you get? There you go. Now we got to substitute back in. It doesn't matter, guys. You can either use the first two, or you could use the second two. Doesn't matter. Which one's the easiest one, though? Probably the first one, right? So this would be m minus n equals -9. So -1 minus n equals -9. All right, we're going to add that 1 over. So we get -n is equal to -8. Get rid of the negative, and n is 8. And Kenan brought up this question earlier. How do I write these in an order of error? Which one goes first? Alphabetical order, -1, and then 8. And so if I were to graph those, what kind of graph would it look like? There you go. It had one solution. All right, let's look at number 2.
So when we do this, we don't have to write what do we look like?
No, I just want you to understand that they all mean the same thing. They're just 3 different ways to get to the same. I can still get to Walmart by going all the way down here in Montevallo and going back up the interstate, or I could just go out 31, or I could go up Highway 11 and then back around. I mean, I can still get to the same spot. I'm just going to go about it a different way. All right, number 2, I'm using elimination. So look back at your note that you wrote. If I'm using elimination, what has to happen? Beautiful. Same number, same letter. Do I have that with X's or with Y's? No. You got to make them. Which ones do you want to make? The X's or the Y's? Probably the X's. They're smaller, right? All right, so think about this. What number does 2 and 3 both go into? 6. So what would I need to multiply the 2 by to make it 6? 3. And then what would I need to multiply the bottom by, the 3 by, to make it 6? 2. So you can distribute the 3 to all of them. Distribute the 2 to all of them. Yes, sir? You sure? All right, so the word is elimination. Look at the 12s. They're the same now. So how could I eliminate them, make them go away, make them become 0? Could I add them or subtract them? Add them. If you subtract them, that'd be -24. So 6 plus 6 is 12x. 12 plus -12 is 0. And 54 plus 6 is 60. Divide it, and what's x equal? 5. Now, you have 4 equations. You have your original 2, and you have the new 2 equations. Which one of those 4 is going to be the easiest to plug that x back into? Which one? I can't hear you.
The first one.
First one? Okay, let's plug in the first one then. If you plug into the bottom one, you're going to get the same answer. I think it's easy on the bottom too, but it doesn't matter. It'd be the same thing. To each its own. Everybody's going to be different. So it'd be 10 plus 4y equals 18. 4y equals 8. Y equals 2. You still get y equals 2? Yep. All right, so what's your order pair? 5 and 2. Perfect. Y'all okay? All right, let's keep going. Here we go. Next page. All right, let's do number 3, and then the rest of those are going to be homework, okay? All right, number 3, here we go. When you use elimination, what do you have to have? Same variable, same number, right? You got 2 and 4, and you have 1 and 2. Which ones do you want to be the same? Doesn't matter. 1 and 2? Okay. So to make 1 and 2 become the same, I would need to multiply this one by 2. I definitely read it. That seems to be an X. And what do you notice happened? They're both going to be the same. If I add them, they're all going to be 0. So it's 0 equals -2. Is that true?
No.
No. So we called that a no solution before, right? So if it's a no solution, what kind of a graph made a no solution?
Inconsistent.
The inconsistent one, the parallel lines. Are y'all okay? All right, so I'm going to hand back your test. Your homework tonight are these 4 problems. If you've got 5 minutes, you can at least get 1 or 2 done. See if you can get one or 2 of them done, okay? And I'm going to hand back your test to you. How long do you have to do test corrections?
1 week.
1 week. Yep. All right. 4, 5, 6, and 7. Y'all try those.